Okay, so thank you for coming to my presentation, which is about web APIs in general and MicroProfile GraphQL in particular. A few words about me. I am Jean-François James. I've been working at Worldline, the European leader in payment technology. I'm a software. I started using Java many years ago when it was young and trendy, and despite its maturity, I believe that Java has the power to renew itself and to stay relevant for modern cloud-native applications. 2 years ago, I took the opportunity to contribute to an Eclipse open source project, MicroProfile GraphQL. And in doing so, my ambition was to help promote the use of GraphQL by Java applications. The point is that GraphQL has grown in the JavaScript ecosystem, where it is identified as a viable solution. Its use by Java applications remains confidential, even though it is a powerful and mature API technology. I want this talk to be as pragmatic as possible and to provide you with just enough information to start your MicroProfile GraphQL journey. We'll start with a bit of history about the origins of GraphQL. We'll make a high-level comparison with REST. We'll have an overview of MicroProfile and a focus on MicroProfile GraphQL. We'll make a demo before having a conclusion. So welcome to the API economy. APIs are everywhere, and we are surrounded by API-driven applications. And in that domain, REST is king. It has been the de facto standard. It has been widely adopted over the last decade and is backed by a strong ecosystem. REST takes its root from a doctoral dissertation written 20 years ago by Roy Felding, where it is defined as an architecture style. That means a set of constraints for web applications. GraphQL is more recent. It was born at Facebook in co-created by Lee Byron, the smiling guy on the picture. It is a specification. It has been open source in 2015, adopted by GitHub 1 year later. And since 2018, it has been governed by a dedicated GraphQL Foundation under the umbrella of the Linux Foundation. Comparing GraphQL with REST is a bit like comparing NoSQL with SQL. There is no silver bullet, and choosing the right solution depends on the use case and the context. The core concept of REST is the resource, a resource being anything that can be named, for instance, a business entity or a business workflow. The core concept of GraphQL is the schema. The schema defines both the data and how we can operate on them. It acts as a strongly typed contract between the API and its clients. By construction, a REST application exposes several endpoints, each being dedicated to a given operation action on a resource. In contrast, a GraphQL application exposes a single generic queryable endpoint. REST makes great use of HTTP semantic, leveraging its verbs, status codes, caching mechanism. GraphQL is totally transport agnostic. Documenting a REST API requires an additional technology such as OpenAPI. GraphQL has a built-in schema-based documentation. The GraphQL query language is very flexible and enables data selection per request. You ask for the exact data you need, multiple queries at a time in a single round trip, network round trip, and partial results. This feature will be showcased during the demo. Ease of use is a key characteristic of REST, but that doesn't mean that doing REST well is easy. Many so-called RESTful APIs do not comply with the architecture style, and Roy Felding himself has often complained about that. Richardson model differentiates 4 levels of maturity for REST APIs. And the highest one, hypermedia, is relatively complex to implement and seldom used. From that perspective, GraphQL is easier to use. But what is REST GraphQL exactly? It is a specification. The document is publicly available, it's pragmatic and easy to read, and this specification defines both a query language and a runtime to execute those queries. The query language defines 3 kinds of operations. Query for read-only operations, mutation for write-read operations, and subscription. The runtime part describes in a very precise way how a GraphQL engine is expected to behave. There is a reference implementation written in JavaScript, and you can find many other implementations complying with the specification in different languages such as Java, PHP, Go, Rust, and so forth. There are still some misunderstandings about GraphQL. Let's clarify 2 of them. First off, GraphQL is not about databases. It's a way to talk to web APIs, not databases. It is intended to sit on top of your business logic, just as REST. It's not about formal graph. It doesn't mandate you to model data in terms of nodes, edge, explicit relationships. It's about naturally interconnected data that make it super clear the capabilities of the API. Well, you know almost everything about GraphQL. Let's switch to MicroProfile. MicroProfile is a platform to develop cloud-native applications. At least this is my definition. It is based on a set of specifications covering key aspects such as observability, fault tolerance, web APIs, configuration, reactive messaging. There are 2 kinds of specs. Some are part of the core, which is versioned and released in a consistent way. Others are so-called standalone specification, and GraphQL is one of them. Let's focus on MicroProfile GraphQL. It started end of 2018 with nice people such as Andy McWright and Adam Anderson from IBM, Philip Kruger from Red Hat, Bojan Tomic, the founder and main contributor of Speaker. Speaker is a GraphQL Java framework that has greatly inspired our work. And I was accompanied by Jean-Baptiste Roux, a colleague from Worldline. 2019 was relatively busy, even if not spectacular in terms of delivery. First, we had to turn our proposal into a specification. Then we had to work on the 3 parts of the specifications: the programmatic API, the documentation, and the technology compatibility kit. So it was a lot of work in the background before being able to release anything. A first milestone has been released in May. GraphQL 1.0 was released in February 2020, and it is now available on Quarkus, OpenLiberty, and Wi-Fi. As far as I know, the development is ongoing on Oracle Eliden and Tomi. Enough speaking, let's go for a demo. So, the demo is based on 2 services, merchant contract and payment scoring. Merchant contracts is about how card payments are accepted by merchants. Payment scoring provides some business metrics about the payment activity per merchant. These 2 services are totally independent. They share nothing except a score ID to retrieve the scores of a given merchant. They both expose a REST and GraphQL API, and we are going to use Swagger UI and Graphql to play around with them. In reality, those 2 services should be developed and run on totally different systems. For this demo, and for the sake of simplicity, they are developed and deployed in the same way. The code is available on GitHub, so feel free to reuse it. It may be a good starting point. It is available on OpenLiberty and Quarkus, and we are going to use both of them during the demo. Let's switch to the demo part. So we are going to start with the REST API using Swagger UI on Quarkus. Our two services are exposed, merchant contract and payment scoring. And we can, for instance, get data for merchant 1. Let's run it. Here it is. We can see that merchant is a relatively complex object with multiple attributes such as card schemes, list of contacts, payment channels, postal address, and so on. The code that implements this endpoint is based on JAX-RS and MicroProfile OpenAPI for the documentation. First, we find the merchant by ID, and then we generate a JSON object containing both the merchant data and the ATOS link, and then we return the result. Nothing very complex. So far, so good. But what if a client is just interested in the card schemes? With this endpoint, it has to retrieve the whole merchant data. This is what we call overfetching, reading more data than really needed. Of course, we could implement an endpoint, a dedicated endpoint that just returns the cards. But what just wants the contacts, another one just wants the payment channels, and so on. This could quickly lead to endpoint proliferation, which is not maintainable. How does it work with GraphQL? So this is GraphQL running on Quarkus. GraphQL is similar to Swagger. It enables to play around with a GraphQL interface. We have two panels, on the left to edit query and on the right to read the result. So this operation is a query that enables to retrieve the card schemes for merchant 1. Let's run it. As you can see, we have just the data we need, no more, no less. And we can easily add other fields, business activity, brand name. Again, we have just the data we need. How does it work at the code level? Very complex, as you can see. We have a find by ID method which implements this query, and this find by ID method retrieves the merchant by ID and returns the result. That's it. It is annotated with a specific query annotation to indicate that this is a GraphQL query, and we have optional description and name annotations for the documentation. And this single method, very easy method, enables a lot of flexibility on the. But how does it work behind the scene? We have a documentation explorer panel on the right. Let's expand it. That enables to navigate in the schema in a user-friendly way. We can deep dive in the query, the data type. We also have mutation to create and delete merchant. In fact, the schema is available at a given URL, schema.graphql. We have a static representation of the schema, including all data and operation definitions. It's very similar to OpenAPI. But we can do more with GraphQL. With this query, we have a description of all queries and mutations. That means that the schema is itself queryable. This is what we call introspection. And this introspection capability provides a lot of flexibility on the client side to use the API and its documentation in a user-friendly way. We can also ask for different data for multiple queries at a time. In this case, we ask for different data for merchant 1 and merchant 2. Okay, so far we have not used our scoring service. Let's explore it using Swagger UI on OpenLiberty. As we can see, this is a very basic service enabling to retrieve some business metrics according to a merge score identifier. And with these APIs, with this, if we want to aggregate both merchant data and score data, we need two calls. The first one to read the merchant data, including the score ID, and the second one to read the score data. This is what we call underfetching. We do not have enough information in the first call, and we need another call to have the whole data we need. How does it work with GraphQL? Let's switch to GraphQL, this time on OpenLiberty. First, let's see the code. We have a getScores method that returns the list of scores for a merchant. Nothing very complex. We check if the scoring service is enabled for that merchant, and if yes, we return the score. As you can see, the merchant parameter is annotated with source, and this makes score data available to all merchants. It extends the merchant GraphQL type by an externally defined field. And this is the magic of GraphQL. How does it work on the client side? Very easily. You can see that in the same request, we aggregate both the merchant data and the score data. But what if a reason or another, the scoring service is not available? How does it work at the GraphQL level? To simulate this, I have implemented a very complex error on scores method, which shares the same signature as getScores and throw a runtime exception. So to simulate this, we just have to replace scores by error on scores. What happens in that case? We can see that there are two parts in the response. The first one indicates that an error has occurred while calling the scores. And the second one includes data coming from the merchant, because these data are available. This is what we call partial results. So far, we have just read the data. We can also easily modify them. Let's create a merchant. We have created merchant 21, and we can as easily, delete it. Here it is. Again, the code that implements this mutation is very easy. We have a create merchant method which just call the underlying service to delete the merchant, and the same for to create the merchant, and the same for deleting it. Both methods are annotated with mutations. By the way, we can see here that MicroProfile GraphQL follow a code-first approach. That means that the GraphQL schema is derived from the code. An alternative approach is called the schema-first approach, when you design the schema upfront using a specific DSL, and afterwards you develop specific classes that implement this schema. The main benefit of the code-first approach is that you have a single source of truth, which is the code. You do not have to play with multiple artifacts. So that's it for the demo. Let's go back to the presentation. So the presentation has been made with MicroProfile 1.0. This is a good starting point, but this is not the end of the story. And we have plenty of improvements in the backlog. We have defined 2 client APIs, a high-level one based on Java interfaces and very close to MicroProfile REST client, and a dynamic one close to the GraphQL query language. Other areas of improvements are better integration with other MicroProfile specifications, in particular metrics and JOT, pagination made easy for large datasets, GraphQL context injection to make the server aware of the calling request, fully aware of the calling request, GraphQL data loader integration to optimize execution of complex queries by introducing caching and batching mechanism, and why not a query cost analysis. To wrap up, GraphQL is a powerful API technology which is particularly relevant to expose rich data models. We also speak of data-intensive API. It enables to provide maximum flexibility on the client side, which can be a great benefit if you have different kind of client technology. Client technologies is requiring its own specificities. So you can provide a lot of flexibility on the client side without suffering from the endpoint proliferation. It's also very powerful to aggregate in a consistent way different data sources and services. What are the challenges to adopt GraphQL in an organization? First, it is a new technology to introduce. It has to be agreed both on the client and server side. It is not a detail of implementation. The schema has to be carefully designed. There is a risk of complex queries, in particular, if the schema exposes cyclic dependencies. And in production, it is recommended to protect against complex queries and to avoid DOS attacks. The API management has to be revisited compared to REST. It cannot be endpoint-based. Remember that a GraphQL application exposes a single endpoint. So if you want to introduce policies, including traffic limiting, access right management, quality of service, monetization, you need to do it at the GraphQL operation level. Modern API solutions such as WSO2 and TIC are GraphQL compliant. They support GraphQL. And last but not least, and this was the purpose of my presentation, MicroProfile makes it easy for you to adopt GraphQL.